All right, so now we're going to look at a first application of derivatives that we discussed, and it's going to be marginal analysis. So we want to learn how to apply the derivatives to marginal cost, revenue, and profit. So remember from section 1.2 that a cost function C specifies the total cost as a function of the number of items X. So C of X is the total cost of X items. The marginal cost function is the derivative C prime of the cost function C. So remember your marginal cost was your slope. Now your slope of your tangent line is your derivative. So C prime of X is going to measure the rate of change of cost with respect to X. So our first example, we are going to find the marginal cost at the given production level X and state the units of measurement. So we're given C of X is equal to 20,000 plus 7X minus 0.00005 X squared when X is equal to 10,000. So first things first, we need to find C prime of X. C prime of X, the derivative of 20,000 is 0, the derivative of 7X is 7, and then we have minus 0.0001 X because the derivative of this is equal to this portion times 2x, and this is what you get as a result. Now, the second part says state the units of measurement, and we need to find the marginal, well, the first part says find the marginal cost at the given production level X. So we need to find C prime of 1,000. Well, that's equal to, you plug 1,000 in for X here, and you get $6 per item. That's it. Next, the marginal revenue and profit. Recall that a revenue or profit function specifies the total revenue R or profit P as a function of the number of items X. The derivatives R prime and P prime of these functions are called the marginal revenue and marginal profit functions, respectively. They measure the rate of change of revenue and profit with respect to the number of items. So, example 2. The Audubon Society at Enormous State University is planning its annual fundraising eat-a-thon. The society will charge students $1.10 per serving of pasta. The society estimates that the total cost of producing X servings of pasta at the event will be C of X equals 350 plus 0.10X plus 0.002 X squared dollars. We, in part A, want to calculate the marginal revenue and profit functions. So the first thing we'll do is write down R of X. R of X is our revenue, and it says that we have 110 per serving of pasta, so that's 1.1x. Our marginal revenue is the derivative of that function. So our marginal revenue is given by R prime of X. The derivative of 1.1x is 1.1. Now, it says calculate the marginal revenue and the profit function. Now, your profit, remember, is your revenue minus your cost. So that's equal to 1.1x minus all of that. So minus the quantity, 350 plus 0.10x plus 0.002 x squared. Now distribute your negative. You get 1.1x minus 350 minus 0.10x minus 0.002 x squared. So we end up with, whenever you simplify, you get negative 350 plus x minus 0.002 x squared, and then we just combine like terms there. So now this is your profit function. Now we want to find the marginal profit, which means we need to find the derivative of P of X. Well, the derivative of p of x is just equal to the derivative of x is 1, the derivative of negative 350 is 0. That's why I jumped right to the derivative of x. And then you get minus 0.004x. And there you go. Now part B, the same problem. Part B, we want to compute the revenue and profit and also the marginal revenue and profit if you have produced and sold 200 servings of pasta. So same problem, we just changed what we've produced and sold. So R of x is equal to 1.1x. R of 200 is equal to 1.1 times 200. That's equal to $220. So that gives us the total revenue. So the total revenue from the sale of 200 plates is $220. Okay, now our profit. We know what our profit function was from the previous page. That doesn't change. It's negative 350 plus x minus 0.002. That's a decimal. We can make it better. 0.002 x squared. And now we find P of 200. P of 200 is equal to negative 350 plus 200 minus 0.002 times 200 squared. Simplify that, you get negative $230. So that means that the society is going to lose money. So the society will lose $230 from the sale of 200 plates. Okay, now R prime of x, because we have to discuss the marginal revenue and profit. R prime of x is just 1.1. We're going back up here and taking the derivative of that function. So that means R prime of 200 is just 1.1 because we cannot plug 200 in anywhere. So that means that the approximate revenue from the sale of the 201st plate is $1.10. Okay, now P prime of x is equal to 1 minus 0.004x. So P prime of 200, same P prime of 200 is 1 minus 0.004 times 200. Well, that's equal to 0.2. And that means that the approximate profit from the sale of the 201st plate is 20 cents. Okay, so even though I didn't write it, note that for R prime of x, that means that the approximate revenue from the sale of the 201st plate is $1.10. And for P prime of x, or P prime of 200, that means that the approximate profit from the sale of the 201st plate is 20 cents. So write that down if you need to. Now, part C says for which value of x is the marginal profit 0. Now the marginal profit is 0 means we set P prime of x equal to 0. So P prime of x equals 0 means we take this equation here and we set it equal to 0. So that means 1 minus 0.004x is 0, or we solve for x, you get x is equal to 1 over 0.004, which means x is going to be 250 plates. Now, it says for which value of x is the marginal profit 0, so that means we get 250. Okay? Now, if you graph the profit function, if you graph the profit function P of X, which is right here, if you graph this function, then what it's going to look like is going to be a parabola with the vertex at X is 250. So the loss is going to be a minimum when you produce and sell 250 plates. So it's going to look like a downward facing parabola, which means you're going to have a loss. All right, that's it. Make sure you review and do your homework problems.